Good morning, everyone. Welcome to the first lecture of problem solving and computer programming course. So, in this lecture, we are going to see some of the foundation of computer system, the basic elements that are used in the computer system, the basic terminology what we are going to learn in this particular subject. So these basic terminologies we are going to see in today's class. It is again a introductory class. So this is the agenda for today. After the end of this particular lecture, you are going to get four things. One is you will be familiar with the computer system, right? Because you are new to the computer system, so you will know what are the components that are available in computer systems, which component is called what, right? Second, I'll tell you what is the main motivation of this programming, why it is required, what type of problems we are targeting to solve using this particular subject, right? Then I'll tell you the very introduction of C++, very fundamental things, C++. Then once you have written a particular program, how you are going to test that program or how you are going to debug that program. This is the agenda for today. So after the end of this lecture, I am expecting that you are going to get some details about these 4 points. Come to the first one. What is a computer program? All of you have a computer. If you don't have also, you have seen or you have used the computer system while you are filling a particular form for an entrance examination, right? Or while downloading a material or to browse the Gmail, okay, or any email you are using like Reddit mail, Hotmail, so many emails are there, whatever emails you are using, Yahoo email, right? So you have used the computer, right? And while you are using the computer system, you are writing something, right? And you are giving a set of instruction to the computer. Based upon your instruction, the computer is working whatever the work you have assigned to the computer, right? For example, you want to browse a particular website. So you have used a particular computer system. You are writing, you have opened a browser, let's say Google Chrome. In that, you are browsing nitw.se.in, right? So what is the process? So for browsing this particular website, you need a computer system. In that computer system, you require a web browser, right? Web browser is nothing but the Google Chrome, Internet Explorer, Mozilla Firefox, right? So these are the web browser. In the web browser tab, you are going to write a particular website name. Then you are going to the home page of that particular website. This is the process you are following. Similarly, let us take another example. Suppose there is a robot. You assume that there is a robot is there, right? And this is the source position of the robot, right? Where the robot is present. And the robot want to reach to a destination position which is present here, right? So what the robot will do? The robot should find a path from the source to the destination, right? So what kind of operation the robot can do from the source location? It can move forward, it can move backward, it can move left, or it can move right. Okay, subjected to there is a road or there is a path available in the left side or right side or forward or backward, right? For example, you can see that there is a obstacle here, there is another obstacle here. So one person can say from the source, the robot is going to take forward direction. Once it reaches this particular point, it identified that there is a obstacle. So it will move towards the left side and it will continue, right? Once it is reaching here, there is another obstacle. It is again moving left and going straight, right? And at this particular time, it is taking left to reach to the destination. So what we are going to do? whatever operation is available for that robot, that we are applying in each and every step. Like you can see, this is a you can say forward operation. This is a left operation. This is again a forward operation. This is a left operation, forward operation, then left operation to reach to the destination. So who is going to tell these instructions? Who is monitoring the robot? Suppose you are monitoring the robot, then you are going to specify these instructions. Okay, either you are aware of this environment, that's why you are saying move forward for let's say 10 meter, then take left for 2 meter, then move forward for let's say 9 meter, and move left for again 5 meter, something like that instruction you can give, right? So if you go for a program, already you can specify these instructions so that any number of robots want to move from the source to the destination, they can follow that instruction, right? Similarly, suppose I will tell you another example. Suppose I will tell you 2 plus 3. So you will say that for computing 2 plus 3, you do not require a computer system or you do not require a calculator, right? So this 2 is a number, 3 is a number, plus is something called as an operator. Okay. So you are adding 2 plus 3 in order to say it is equal to let's say 5. Right? But what happens if I give a 5, 12 digit number as a first input, followed by another 5, 12 digit number as a second input? Then this calculation may require your calculator if you don't want to solve using manually, because manually it will take more time. What you can do, you have to take the help of a calculator if it is possible for that calculator. If not, you can go for a computer program to calculate the addition of two numbers. Where the first number is a very big number, second number is a big number, so you are going to add it, right? So the same thing we want to achieve through a computer program. Manually we can do many work. Many works can be done manually. In early days, people are doing the works manually only. But when the complexity of the work is increased, like here you can say from a 1-digit number to I am moving to 5 12-digit number, then you cannot do it manually. You need an automatic process or a program in which you are going to set a set of instructions. Set of instructions means you can say a computer program, you have written a computer program. In that you are specifying the first number you take, second number you take, add these two numbers and produce the output. So these are the instructions we are following. First is a number, second is a number, third is there is an operation, addition operation, fourth is a result. That's why a computer program is nothing but a set of instructions for a computer to follow, right? Why you are heading towards the computer program? Because manually we cannot do every work. It is not practically possible to do all the works manually. That's why we want to write some code or we want to give some instructions, like you have seen here we are giving a set of instructions to the robot to reach to its particular destination. Or in the website case also, you are following a sequence of process in order to reach a particular web page. Suppose you want to see your timetable in the institute website. Then you have to follow a set of instructions or set of process in which you can reach to the destination, right? Or a target. You can say targeted website, targeted page, or target that you have to reach with a set of instructions. Right? So we are going to write the set of instructions. How we can write the set of instruction? For example, you will tell your friend today we will go for restaurant. Then you will make a call to you have to open your contact list. You have browsed your phone, your friend's mobile number. You call him. He picked the phone. Then you told that okay, today we are going to take dinner or lunch in a particular restaurant, right? So this is a manual process we are following. How to automatically do this process through a computer, That is nothing but for that we require computer program, right? How you will convince the computer that this work the computer need to do? For that you require program. Computer may not understand your local language. We have plenty of local languages are there, right? Many languages are there. Computer may not understand. So we have to use a particular program which is written in a language. Let it be C or C++, whatever name you have studied, you have heard from various sources. So that programming language you have to use to write a computer program. Right? It may be C, it may be C++, it may be Java, or it may be nowadays very famous one, that is Python. Right? So that will help you to write a program. Right? Irrespective of the language, you are giving instruction to your computer to perform a particular task. Right? This is the first one. Second is, what is a computer software? So you are habituated with a lot of computer softwares. The very first one you can see that you are using a word processor, Microsoft Word, Microsoft PowerPoint, Notepad you are using, WordPad you are using, PDF file you are using. So all these are called as the software. Okay. Again, whenever you go for the software classifications, you can find there are some softwares are there which is essential to our computer system. And there are a few softwares are there which are not essential for us. Right? Even if it is not there in your computer system, the computer system will work. So based upon that, it is divided into two parts. One is called as your system software. Second one is called as your application software. Okay? System software, another is called as your application software. So system software is an essential thing. If system software is not there in your computer system, then your computer will not work. Like whenever you are purchasing a particular computer system, you are installing the operating system, right? So this operating system is treated as a system software. Without that, doing any work is not possible, right? The second one is application software. Application software will give you a more flexibility. Like you can see earlier Notepad, WordPad is there. Notepad, WordPad is not that much user interactive or that much giving flexibility to the user, for which Microsoft has launched Microsoft Word. Again, Microsoft Word has a lot of versions, right? Now we are using 2020 version or something like that. So these software, even if the software is not available in a computer system, your system will work. But the problem is that you will not get a greater flexibility. Okay, that's why we are installing up many application software so that easily we can do the work. For example, I will tell you, you create a Word file, convert it to PDF file. You don't have any software for converting Word to the PDF. So what you have done, you have searched some software, and the trial version of that software you have installed to your computer system. Even if the software is not available, then also your system will work. Okay, your system will work without any problem. But it will give you a good flexibility that anytime you can convert a Word to the PDF if you have installed it. That is called as your computer software. Okay. So generally, there is two things you try to understand. There is a program, okay, there is a software. So there is always a difference between the program and software. Both are not same. Software, there is a documentation is there. Like whenever you are installing a particular software into your computer system, you are agreeing that terms and conditions set by that software owner. You remember, whenever you are installing, just you look out that one. Whenever you are installing a particular, it is saying agreement. I accept the agreement. If you will not accept the agreement, the software is not going to install. Even if whatever program you are writing, for C or C++ or whatever you will write entire semester, that is also coming under a particular software. Okay, that is also coming under a software. You are installing a C software, let it be whatever software I will tell you later, right, in the lab class. Once you install that software and accept the terms and conditions, in that you are writing the program. So in a general sense, what you can say, the collection of program used by a computer is called as a software. Collection of program. One program meant for X work, another program meant for Y work, another program meant for Z work. All they are combined together to form a software. And in a software, there is a documentation is there. If you go to a particular software folder, you can see there is a README file is there, or some instruction file is there, or some configuration file is there. So software, you can say it is a formal one, but program is not that much formal, right? And this collection of program is meant for different purposes. One may be based upon the editor or the text editor. One program I have, or one software I have, in which there are several programs are there. One program is meant for one editor or a text editor. You can open a Word file under the Microsoft Word. So this Word, this file is under our Microsoft Word. You can create multiple Word files under Microsoft Word features, right? So, especially in this programming, one very popular editor is used, that is called as a BI editor. Especially in the Linux system, okay, you can use a editor which is already there. Whenever you will install Linux system into a computer system, BI editor is automatically there, right? So for that also, a set of code is written in order to run this BI editor. Whatever the instructions you are giving into the BI editor, for that also, some code has written by someone, right? That's why it is always a difficult task to become a system engineer rather than an application engineer. System engineer is defining the work which is used by the application programs, right? That's why system engineer is having more value than the application program, okay? Because you have to understand the internal functionalities of the computer system. Based on that, you have to write. Like I told you, in the robot case, you are applying left, right, and forward and backward operation, right? Now you will ask, whenever you are clicking left or giving instruction left, how robot is going to know that you want a left operation? Or how the robot is going to know that you want a forward operation? For that, whatever code you are writing, that is the responsibility of the system programmer, not the application programmer. As an application program, what we are doing, we are utilizing these functions which is specified by a system program, right? That's why you have to concentrate in the system programmer if you rather than go for application program. Application programmer, many people are there, but writing system program is very much important. Okay, so this program, the collection of program may be anything, like you can see here BI editor, or the very simple notepad you can see in your computer system, or if you have installed Java, or if you are aware of Java, Java is running under one platform. Let it be NetBeans, right? So NetBeans is a platform where you can write, you can create the Java project, you can run the Java project. Similarly, gedit is there. A lot of things are there. No need to go through this thing. You understand, all a particular software consists of a set of programs, where each and every program may be meant for different purposes, right? The next one, there may be a translator. Translator means what? Suppose I don't know X language. Okay, as a person, let's say I do not know X language. But another person, the person number 2, let it be person number 1 and person number 2. Person number 2 know this X language. And whatever language I am speaking, that also aware of, that also this person number 2 is compatible, right? So what this person can do, suppose I am giving him in Y language, okay, he will tell the things in Y language, where he is converting this X language in between. I'll say that I do not know a particular language, right? Let us go to a particular language. For example, I know only Hindi and English, right? I do not know Telugu. So what I'll tell to one of my friend who know Telugu, well, Hindi and English, I'll tell everything you have to convert to either into Hindi or English, right? So I may tell in Hindi and English that please convert the whatever text is there in a book, or whatever text we are watching in a movie, or whatever text you are seeing in a poster. Please convert this thing and tell me in Hindi and English. So what you need here? You need a translator. Translator is converting one language to another language. Okay? Because we are not aware of all the languages. That is the reason the translator is converting one language to another language. To be very specific, here you can see whatever language our computer understands, that language may not understood by human being. We may not aware that what is computer understand. Similarly, whatever we understand, computer may not understand that thing. So what we need in between the computer and human being or a user, we need a intermediate person. That is nothing but a translator. The translator is going to convert your word or your thought or your sentence into computer language. That's why translator is required. From converting one language to another language, so that the second person can understand what you are speaking. Right? Similarly, another type of thing. Okay, I will come to this compiler interpreter later, right? You have correctly pointed out, but I will come to later. Next is your system manager. System manager is managing your system. Many softwares are there, many hardwares are there, right? You can see in your computer system, device manager is there, a lot of devices are there. So you have to monitor these things, right? Because sometimes you require a device to give input. Sometimes you are giving your work to print a particular thing through a printer, right? So that is also a device. You have a Bluetooth headphone, that is a device. You have a wireless mouse, wireless board, these all are your devices. So system manages everything, right? Not only the software, not only the hardware, it manages entire thing so that smoothly you can use the computer system, right? Now, there are three main classes of computer. First one, what we are using now, that is our personal computer. Personal computer is our laptop, or you can say desktop, right? Nowadays, our mobile phone has also such features. Whatever available in our personal computer, the same thing is available in our smartphone, right? So personal computer does not mean that only it is a desktop system or laptop system. It is any system where you can do your required work. But what happens? Generally, it is dedicated to a particular person. If you are using a computer system, at the same time, if I want to use that system, then I have to wait. That's why it is saying it is small and it is used by one person at a time. Once your work is over with a computer system, I can use that system. But I have to wait if you are using that computer system. Right? So, multiple people cannot use the same system. So, if you go for a big application, if you go for a very big application where multiple users need to interact at the same time, PC is not the right choice. PC is not the appropriate destination if multiple people you want to do a common work. Okay. In order to enhance the capability of the personal computer, capability means what? The storage capacity, how much data you can store in a computer, or how many files you can store in a computer system, how much files you can process in your computer system. If you see that personal computer is having limited power, it can store a less thing, limited thing, it can process a limited thing. But many people, whenever you will go to the final year, you will do the project in your respective domain. So what you have to do, you have to deal with, you are going to deal with a very big work where the number of the capacity of the storage, whatever you require, is more. or the computation you whatever you require, that is not sufficient with the help of a personal computer. If such a work you want to do through a computer system, then what you have to do? You have to switch to workstation, where workstation provides you more capacity, more computational power than your personal computer system. But workstation is also having its limitation. Like here you can see, workstation is very larger in comparison to the personal computer, and it is more powerful than a personal computer. But still, if your work is not done by workstation, then what you will do? You have to go for the mainframe system. Okay, so mainframe systems are larger than these PCs and workstations. And one advantage is that if you are working for a group project in which you require storage or you require computation, then multiple user also you can work in a mainframe system. That is the advantages you are going to get, which is not available in the personal computer and workstation. Okay, but the main demerits is that for maintaining everything, you require supporting staff. In the mainframe system, it requires support staff. Without support staff, it is not possible. So one of the typical figure I have taken from the Google, you can see this is the mainframe computer outer lookout, right? Some person may say that, sir, I have one computer system, my friend is having one computer system, I have 5 friends, all are having computer systems. So whatever work I want to do in a single computer system, in my computer system, it is not sufficient. But when I am combining the work of the capacity of my friend's computer system, it is satisfying my requirement. For example, this computer he can store 100 GB of data. Let it be a small figure, right? And his friend's computer system can store 200 GB of data. Here is 400 GB of data. Okay. Here 200 GB of data. Here 100 GB of data. Right? Let it be a small figure. So you can say that I want to store 1000 GB. What you can say? My computer is not sufficient to store a thing, but if I combine the work with or collaborate with my friends, together we can provide 1000 GB. So you can say 400, 200, if you add this thing, I think it is coming 1000. Yes. So what you can do? You have to connect these computer systems through a network. Network means some connection should be there from here to here, here to here, here to here, again here to here, or personally from this computer system to individual systems, so that you can acquire the storage available in your friend's computer system. Right? So that is the reason when there is a scarcity of resources with one computer system, you can collaborate with other to achieve it through a network system. Okay, or you can see in your telephone connection, if you remember in old days, we have telephone, landline phones. Landline phone, some wire is connected, right? The wire is connected to somewhere. Like that, each and every householder, they are using this landline phone early days. So one wire is reaching to their, you can say their landline from a pole, right? So that pole maintains multiple connections. Similarly, they may be point to a single locations where they are connected to each other, or they can interact with each other to provide that massive power, right? So in this way, you can enhance the power of a single computer system which is limited to a very big system. Okay. So whenever you are going, you are think in BTech, whatever you are going to study, that is limited to a single computer system. But you try to explore how we can do programming with multiple systems. I will assign some work to first computer system, I will assign some work to second system, I will assign some work to the last system. So that at a time my work is processed in multiple systems. So very less time I am going to get my output. But if I am restricted to a single system, it is very difficult because its power is limited. Right? In this way, you can classify the computer system. Now, many resources are connected to our computer system. Like you know that if you are using your laptop, you have an inbuilt keyboard, okay, and a mouse pointer, right? Or you may use an external keyboard or external mouse, right? Similarly, people are connecting headphone, okay, with the computer system to listen to the lecture. So a number of devices are connected to the computer. Similarly, a number of computers connected to share resources. What we discussed. Number of resources are connected each other to share the resources. For example, if you go for a printer, a high-end printer, I am not talking about a small printer, I am going for a network printer which is having high cost. So one individual person cannot purchase a personal printer because printer cost is very high if you go for a high-end wireless printer, right? Because the cost of the computer system, if you see, if you compare with the printer, okay, I am talking about the high-end printer, right? The cost is more. So I cannot purchase a printer more costly than a computer system. So what I have to do? I will share that printer with multiple people. Like in an institute, let's say in a particular branch, 200 students are there in each batch. So they want to use the computer system. So for these 200 students, it is not possible to purchase 200 printers. So what I will do? I will provide individual system to these 200 students so they can use the system. But whenever the print work is there, they have to share in a common printer. Okay. So this common printer is used by multiple people. Then in your mind, there may be a question. If multiple peoples are using the same printer, it may possible that there is a conflict. Like multiple peoples are reaching to a particular restaurant for taking food. So there may be a issue that who came first, based upon that will serve the food. Similar case happen in the case of printer. That's why printer has a buffer as well as a queue, you can say. Like in a temple you have queue, right? Whoever reaching to that temple main gate, he has to stand in a queue. And whoever came first, he has to visit first. He or she has to visit first, right? So similarly, if multiple peoples are giving the print command at the same time in order to print their work, then that will be queued in the printer, and one by one work can be printed by the printer. Printer cannot execute multiple works at the simultaneously. At a time, only one print will come. Whether it belongs to X person or Y person or Z person, it is not possible to print 5-6 things at the same time. Similarly, this is not limited to the printer. It is expanded to anything. Like I told you, I want to share my disk space, hard disk space, or I want to share my computation power, that is RAM. I'll come to this term if you are not comfortable. So whatever computer resources is there, that I want to share with others. For that, multiple computers need to interact with each other. Now, there are 5 main components in our computer system. You are habituated with this, but let us formally discuss it. First one is called as your input device. What is the input device you have? You have keyboard. Through keyboard, you are writing something in a Word document. You are typing something. You are giving some instruction through the keyboard. Okay. You are renaming a particular file using your keyboard. Or you are pointing somewhere. You are going to a folder, again subfolder, subfolder, like that you are processing through the input device. So input device allows communication to the computer system, through which you are expressing your thing, which is understood by the computer system. The program is written in such a manner that whatever thing you will type in your keyboard or mouse, whatever instruction you will give, computer is going to follow that instruction. Okay. The next one is your output device. Once your job is done, sometimes you need output. Okay. Output in the not in the form of printer. Output may be displayed in the computer screen as well. That is also called as your output device. Suppose you have written 2 and 3. you have given as an input, you are asking for addition of two number, that is 2 plus 3 in a calculator. Calculator is displaying 5. So the calculator monitor is now your output device, or you can say your computer monitor where you are watching the result or seeing the result, that is called as our output device. So it allows the communication to the user. So whatever user is giving instructions or input, based upon that output is generated, and output is shown by a output device like your monitor, right? In between this input and output device, how input is processed to output? You have given input to 3, right? Through a input device to the computer system, right? How the computer is providing 5? So who convert this input to the output? Now the CPU is the person who is going to convert the input to the output. That we call it a processor. The full form of CPU is your central processing unit. So this processor is having the capability that it can receive some instruction and it can perform some work and it can produce the output which you are going to see through the output device. Right? This is the third component. The fourth component is nothing but the memory. What is memory? In your computer you are storing movie, you are downloading the movie, you are keeping the movie. In your computer system you are downloading some PDF file or your rank card, you can say rank card, your certificates, everything you have scanned and you are storing in a particular place. So for that you need memory. In order to store something you require memory. Let it be your pen drive also. Pen drive also you are keeping your data so that you can take to a nearest shop to take a printout. So that is also having some memory. Some memory capacity, let it be small only. 4 GB or 8 GB or 32 GB, something like that, but it is small capacity, but you can do it. So this memory, if you see the classification, there is a very big classification, but we are going to go for two different classifications. One is called as our main memory, another is called as secondary, right? Main memory, another is called as our secondary memory. So what is main memory? Main memory is used to run a particular program. So whenever you will write a particular program and you are executing the program, main memory plays an important role. Okay. The memory location containing the running program. Suppose you have written a program, you want to check whether the program is working or not, or whether the program, whatever codes you have written, the code is correct or not. So that will be processed in a main memory, right? And generally you know that main memory size is small than your secondary memory. Like whenever you purchase a computer system, what you are saying, I need 4 GB of RAM. If you are not comfortable, I will tell later. Okay. You are saying I need some 4 GB or 8 GB of RAM, right? And whenever the hard disk is coming, okay, hard disk drive is coming, so you are saying I need 1 GB of hard disk or 512 GB of hard disk, or nowadays people are also saying 2 GB or 4 GB of hard disk. Okay, so secondary memory, you can see the size is more in comparison to your main memory. Main memory size is small in comparison to the secondary memory. So main memory processes that thing, but secondary memory, what it is doing? It is keeping the things. But anything is there in the main memory, it will be not available for all the time. But whatever things you are storing in the secondary memory, it will be there for your lifetime, until unless you are going to delete it. So if you want to maintain the permanent record of data, then you have to store that thing in the disk, that we call it secondary memory. But if you want to run some code or if you want to process something, then you have to use the main memory. So you may store your computer program in the secondary memory, but whenever you want to execute that program need to be transferred from secondary memory to main memory. So you are using the secondary memory to open it, but whenever you are running that program, it is running inside the main memory. Right? So this is the 5 components of a computer system. So this is the complete picture. You can see Here the input device is there, and we are getting output through the output devices, and inside that the processor and main memory is there, and secondary memory is here. So there are 5 components, right? Generally main memory size is small, as I mentioned, and secondary memory size is more. Main memory do the computation or processing, secondary memory is keeping the data as a permanent record. So these are the 5 components used in a computer system. Also, you can visit John von Neumann architecture. In John von Neumann architecture, you can see what are the components a computer system has. Please go through it as an assignment. You go for John von Neumann architecture. The next one, come to the main memory. If you go for main memory is not for the permanent storage, it is for the temporary, but secondary memory is for your permanent. So main memory or secondary memory, you go for any memory, you have a list of memory location. Like in a particular village or in a particular town or a particular city, you have several homes, right? A lot of homes are there, right? Similarly, inside the main memory and secondary memory, there are many locations are there. Like in our street also, many houses are there where people are staying. Similarly, in computer memory, you have a long list of memory locations. And they are consecutive to each other. Like one house is consecutive of another house, right? Similarly, here also the memory locations are consecutive of each other. And what is the capacity of this particular memory locations? Now they can store either 0 or 1. So you can see here you can store in the location either 0 or 1. Either 0 or 1. Not both 0, 1 at the same time. Right? They can store a bit that is either 0 or 1. Right? 0 indicates something, 1 indicates something, or a group of zeros and ones, that is nothing but a group of memory location may mean something. That we are going to discuss later. Okay? So, but each location is capable to store either 0 or 1, not both at the same time. And if required, sometimes you will say that no, I want to change this location value from 0 to 1. So it is possible. You have to replace 0 with 1. But you cannot say that in a single location I will store 0, 1. It is not possible. You can replace it, you can change it. During the program execution, you can replace these things or you can update with a new value. There is no problem. So this 0, 1 logic is called as our binary digit. Binary means 2. 2 means either 0 or 1. Right? Similarly, we have another number system, that is octal number system. Octal means your 8. Okay? 8 means it will start from 0, 1, 2, 3, 4, 5, 6 and 7. The total 8 digits are there. That is octal system. Similarly, if you go for another number system is there, that is called as hexadecimal system. Hexadecimal system indicates your 16 numbers, right? Starting from 0 to 9. 0 to 9 is a 10 number, then followed by A, B, C, D, E, F, where A represents your 10, B represents 11, C represents 12, D represents 13, E represents 15, and F represents 16. Okay? A is 10, A is 10, and B is 11, C is 12, this is 13, this is 14, this is 15. So the value is in between 0 to 15, so 16 numbers are there. So, but in computer case what happens? Computer only understands this binary bit, not this octal system or not this hexadecimal system. But why we are using these number systems then? We are using these representations for easy interpretation. As a human being, if I show that 512 digits of 0 and 1, you may not understand. But if I use a hexadecimal system or octal system, this 512 bit can be reduced to a small number of bits, okay, or small number of digits, so that you can understand a particular thing. Right? So there is a concept of bit. Bit is either 0 or 1. So bit is capable to store either 0 or 1. Similarly, if you have 4 bit, like I occupy 4 locations, one location, second location, third location. In the first location, you can store either 0 or 1. Second location also you can store 0, 1. Third location, fourth location also you can store 0 or 1. So if you gather 4 different bit, you can call that one is a nibble. So nibble is a 4 bit. Similarly, you can gather another 4 bit. Okay. For total you have 8 bit system. Okay. 8 bit means you can in 8 locations, in location number 1 to 8, you can store the value 0 or 1. These 8 bits are called as our byte. Right? 8 bit is called as your byte. First is 0, 1 is bit, 4 bit is nibble, 8 bit is your byte. Right? And address. Address means, suppose I will ask you where this X person is staying in your town or in your village or in your street. Then you will say that his house number is 123. Or you will say his house number is 145. So what you are telling me? You are telling his home address or home number, so that I can easily locate a particular home. So for that you require address. Okay. So what address is saying? A number. Address is a number that identifies a memory locations. Like I told you, there is a long list of memory location, right? If there is a long list of memory location, then what you have to do? You have to represent each and every location with the address. Like in our street, each and every house is given with a house number. So if a post PM will come or if a person will come with the house number, he can easily or he or she can easily locate it. For that you need address. Okay, so with this address only you can locate a particular location. That's why address plays an important role. So this is a complete list of units of computer data. First is your 1 bit is either 0 or 1. 4 bit is called as 1 nibble. 8 bit is called as your 1 byte. After that, everything will come in the power of 2 to the power 10. 2 to the power 10 is nothing but your 1024. If you calculate 2 to the power 10, you are going to get 1024. So when there is a 1024 byte, 1 byte is 8 bit. So 1024 byte means you can say 1024 into 8 bit. You calculate. Okay, this is nothing but 2 to the power 10 and this is nothing but 2 to the power 3. Then you can say it is 2 to the 13 bit. 2 to the 13 bit. So if there is 1024 bytes is there, so we are representing by 1 kilobyte. Similarly, if you have 1024 kilobyte, 1024 kilobytes, then what you can say? It is nothing but 1 kilobytes, then you can say it is 1 megabyte. Right? That is nothing but 2 to the power 10 kilobyte is nothing but 1 megabyte. Similarly, 1024 megabyte is your 1 gigabyte. 1024 gigabyte is nothing but your 1 terabyte, which nowadays we are saying 1 TB hard disks, 2 TB hard disks, right? And 1024 terabyte is 1 petabyte. Till now, we have reached to this particular point in a personal computer system. But if you go for other systems where high-end processors are there, high-end storage are there, or if you consider your Facebook or WhatsApp, you imagine how many Facebook users are there, how many WhatsApp users are there, how many posts are they doing, how many messages they are exchanging. So if you see, the data is in the form of petabyte, some petabyte or some yottabyte or some zettabyte. Some other units are there, but till now we have reached to this particular point, so we will restrict our discussion up to this particular point. But if you are interested, you find 1024 petabyte is what. Similarly, after petabyte, yottabyte is there, zettabyte is there. So you find their proper order. Right? So this is about our computer memory. And some data is too large for a single byte. Sometimes the data is too small, sometimes the data is too large. For example, you will say that I want to store only 3 bits of information. So I will give you a nibble. Nibble consists of 4 bits. So I have assigned 4 location to you. You require 3 bits. So we are saying first bit is 1, second bit is 0, third bit is 1. And the next location is, let's say, not required. Sometimes what happens, you require 9 bits. Okay. So you require 9 locations. So let's say computer is providing in 8-bit format. So your 9-bit is not satisfied with 8 bits or 8 bits of location, right? So what you have to do? You have to go for 16-bit, where you are wasting the 7 bits. 9-bit you are occupying as per your requirement, and 7-bit you are unnecessarily utilizing, right? Because generally we are representing in the form of byte, so we are occupying the location on that basis. Similarly, if you see, if you go for an integer is nothing but your 2, 3, 5, or 100 rupees, 200 rupees. These are the integers, right? Or there is a real number, that is, let's say 100.25, okay, 4.375. So these numbers are not sufficient to represent in a single bit or single byte. So what you need in that case, you require multiple bytes in order to satisfy their requirement, right? But how you are going to locate it? How you are going to locate? For example, in order to save a particular number, I am going to assign you 2 bytes. Let's say this is 1 byte, this is 2 bytes. It is consist of your 8 locations, let's say. So 8 locations are there. So you require 2 bytes. But your address, while you are keeping the address of this particular integer, let's say I am occupying 2 locations for integer. So the address will point to the first location. Once you know the first location, you know what is the second location. The second location is the consecutive location of the first location. That's why address also always refers to the first byte, not to the consecutive byte. Automatically consecutive byte you will go, but you have to point to the first byte. Suppose your 5 of friends are staying consecutively in a hostel room. So you have asked, what is the first address? He is saying room number 100. Then you know the second location is 101, 102, 103, 104, like that. So the next few consecutive bytes like this can store additional bits for larger data. But always you are pointing to the first location. Okay. So now, if you see, this is a typical example. You can see 3 bytes location with address 1. So we are pointing to byte 1. Okay. And 3 byte is stored for a particular number. Similarly, you can say here 2 byte is reserved for address number 4. So if somebody know the address number 1, then he can get byte 1 to byte 3. Somebody know address number 4, so he can get byte number 4 and 5. Somebody know address number 6, then he will go with byte 6 only. Because in order to store that, you require only 1 byte. Similarly, for address number 7, you can go for 3 consecutive bytes. So in this way, you are going to assign the memory to the user based upon their requirement. I will tell you what is the requirement in later state. But if your requirement is 3 byte or 2 byte or 1 byte, accordingly you can assign. But address is always pointing to the first byte. Like here you can see, first byte only we are focusing. We are not going for byte number 2, 3, or 5, or 7, 8 or 9. Okay.